Welcome to The Explainer. Today, we're diving straight into the ultimate cosmic mystery. Is humanity truly alone in the universe? You know, it's a question that's literally haunted philosophers, scientists, and just regular stargazers for generations. Are we actually sharing this vast cosmos with other intelligent beings, or is Earth just a solitary, fleeting spark of life in an endless, quiet void? Let's find out.
There's this chilling quote from the legendary science fiction author Arthur C. Clarke that perfectly sets the stage for our grand cosmic detective story. Think about it. If we're completely alone, well, the immense burden of consciousness rests entirely on our shoulders. But if we aren't, wow, that opens up a universe of thrilling and, maybe terrifying possibilities.
Section 1. The Great Cosmic Silence. We're going to start our investigation right at the scene of the crime, our eerily quiet Milky Way galaxy. I mean, we look out into a universe that seems absolutely tailor-made for biology, and yet we're met with this overwhelming, profound silence. Picture this. You arrive at a perfectly prepared party, but literally no one else has shown up. The music is playing, the snacks are laid out on the table, the lighting is fantastic. That is exactly how our seemingly habitable galaxy feels right now. We're talking hundreds of billions of stars out there, many with Earth-like planets sitting right in their sweet spots, their habitable zones. They've had billions of years to develop complex life. So, where on Earth, or rather, where in the galaxy, are all the other guests?
Way back in 1950, the renowned physicist Enrico Fermi actually asked this legendary question over lunch with some colleagues, and that gave birth to what we now call the Fermi Paradox. He realized something pretty crazy. Any civilization with even modest rocket technology could colonize the entire galaxy in just a few tens of millions of years. And honestly, that's a mere blink of an eye in cosmic terms.
Section 2. Myth-busting the Fermi Paradox. Okay, so what's really fascinating here is that the famous Fermi Paradox as we know it today, it's actually a massive historical misunderstanding. The way we commonly frame it just isn't what Enrico Fermi was arguing at all.
As researcher Robert H. Gray uncovered by actually tracking down and interviewing the people at that original 1950 lunch, Fermi was really only doubting the physics and economic feasibility of interstellar travel. He never actually said aliens don't exist. It was scientists Michael Hart and later Frank Tipler, way later in the 1970s and 80s, who coined the bold argument that the lack of visitors on Earth means extraterrestrial intelligence simply does not exist anywhere.
And there's this brilliant analogy that perfectly illustrates the deep flaw in that logic. Concluding we're alone just because no one is in our solar system right now, that's exactly like assuming bears don't exist just because there isn't one wandering through your front yard at this very moment. I mean, bears have had plenty of time to shamble into your yard over the history of North America, but just because they aren't there today definitely doesn't mean they aren't out in the woods.
Section 3. Why is the party empty? Right, so if we completely toss out that pessimistic Hart-Tipler idea that aliens definitely don't exist, let's line up the suspects for why the universe is so incredibly quiet. There are some absolutely fascinating theories trying to solve this mystery.
Suspect number 1 is the zoo hypothesis. This suggests we're merely a protected exhibit for advanced alien tourists or, galactic sociologists. In this scenario, extraterrestrials are fully aware of us, but they operate under something exactly like Star Trek's Prime Directive. They're intentionally keeping themselves hidden in the shadows just to let us develop naturally. Kind of wild to think about, right?
Then we have a much darker suspect, the dark forest theory. You've probably seen this popularized heavily in modern sci-fi. It's this genuinely terrifying concept that evolutionary survival in the cosmos literally means staying completely quiet to avoid highly advanced cosmic predators. The idea is that the universe is a dark forest, and if you shine a flashlight to say hello, you instantly become a target for elimination. Ask yourself, would you risk turning on that flashlight? No way.
Or, hey, perhaps the silence is just basic economics. Consider this. The energy bill to send a single human colonist on a modest ship just to our nearest neighboring star, Proxima Centauri, would be a staggering $40 billion. At that kind of astronomical price point, an advanced civilization might just look at the math and decide interstellar travel simply isn't worth the immense cost and effort.
And then there's the bleakest theory we have to face, the self-destruction suspect. It is entirely possible that the exact traits required to develop advanced technology naturally contain the seeds of a civilization's own destruction. Advanced civilizations might routinely wipe themselves out, whether that's via nuclear war, climate disaster, or maybe rogue artificial intelligence, long before they ever get the chance to reach out to the stars.
Section 4. A glass of ocean water. Okay, Before we close the case on a tragic, empty universe, let's take a step back and look at the sheer scale of our ongoing investigation. SETI co-founder Jill Tarter brilliantly illustrates the reality of our search with a fantastic analogy. She points out that our hunt so far is essentially like scooping a single 8-ounce glass of water from the vast ocean, looking inside and declaring the entire ocean completely devoid of fish. The truth is, the cosmos is impossibly vast, and we have barely, literally barely, even begun to scratch the surface.
So the crucial point here is understanding exactly how we're actually looking. Historically, we've primarily been listening for radio waves. Why? Well, because space, even though it's mostly empty, contains massive, incredibly dense clouds of gas and dust. If you try to look using optical or infrared wavelengths, the signal just gets absorbed. But radio waves, they can penetrate the galaxy completely unhindered, and we naturally assume any intelligent aliens out there would know this basic astrophysics too.
However, before anyone can broadcast radio waves across the galaxy, life actually has to, well, start. As recent Drake Award winner David Deamer noted, finding the origins of life is step 1. In the famous Drake equation, this is represented by FL, that's the fraction of planets that actually develop biological beginnings. Because without those early chemical processes sparking in shallow pools or deep-sea vents, you're never going to have intelligent beings building radio telescopes in the first place.
Section 5. Modern Alien Hunting Tools. To dramatically expand our cosmic search way beyond that single glass of ocean water, modern astronomers are deploying an absolutely incredible new arsenal of high-tech forensic tools. Out at the SETI Institute's Allen Telescope Array in California, they have this array of 42 synchronized antennas pointing right at the stars. But it's really not just the hardware that's impressive here. They are now processing gigabits of cosmic data in real time, using bespoke neural networks and incredibly fast NVIDIA-accelerated computing just to sift through all that cosmic static. It's a real game changer.
And this AI system recently passed a massive real-world test. It successfully isolated the highly coherent, giant radio pulses of a pulsar spinning in the Crab Nebula, which is roughly 6,500 light-years away from Earth. This served as a vital proof of concept. It proved for sure that the AI can effectively sift through all that chaotic background noise of the universe and actually identify distinct repeating scientific patterns in real time.
The best part? We aren't just listening for intentional radio beacons anymore. According to astronomer Jason T. Wright's research, the whole field is evolving significantly. We're now aggressively using what's called artifact SETI alongside traditional communication SETI. Basically, this means we aren't just sitting around hoping an alien is calling us on the phone, we're actively looking for the accidental evidence they might have left behind in their wake, whether they're still alive today or long extinct.
We call these physical clues technosignatures. By tracking exoplanets as they cross in front of their host stars, we can look for the distinct shadows of giant megastructures. Think Dyson spheres built to harvest a whole star's energy. We can search for artificial city lights or strange, unnatural atmospheric pollution like CFCs. We might even find evidence of nuclear waste dumping, like unusual heavy concentrations of the element praseodymium in a star's atmosphere. Or we could spot the massive industrial waste heat of a planet-spanning society just glowing brightly in the mid-infrared.
We're even applying game theory directly to the cosmos to identify what are known as Schelling points. These are mutually obvious times or places chosen by two parties who simply cannot coordinate beforehand. For example, astronomers might guess that the absolute most logical time for an alien civilization to broadcast a signal to Earth is the exact moment their planet is visibly transiting its star from our specific perspective. It's literally a brilliant cosmic game of hide-and-seek played out with advanced mathematics.
So, as we unleash artificial intelligence, pinpoint complex exoplanet transits, and hunt for the glowing embers of alien industry, our entire perspective on the cosmos is shifting. The question is no longer just Fermi's, where's everybody? As we finally gain the actual technological capability to detect our galactic neighbors, the much bigger question we have to ask ourselves is, what will humanity do when we finally find them? Are we truly ready for the day the great silence is broken? Think about that for a second. Thanks for joining me for this explainer, and keep looking up.